First, we'll see few things. We'll see what is an element, what is an atom, what are the subatomic particles, what is an isotope and a radioisotope. So we'll talk about those few things first. We'll also talk about the chemical bonds. The chemical bonds hold the atoms together. So the attraction, bond is the attraction between the atoms. So we'll see what are the important bonds that hold the molecules or atoms in our body together. Then we'll talk about the chemical reactions, important types of chemical reactions that occur inside the body. Then we'll talk about the organic and inorganic compounds. Your body consists of both organic and inorganic compounds. So in your body, you have both organic compounds and inorganic compounds. So we will see what are the organic and important inorganic compounds in your body. The most abundant or common chemical of the body is the water. So water is the most abundant. Human body mainly consists of water. So we'll talk about the water, properties of water. Then we'll talk about the acid and the base. Both acids and bases are present in your body, and we'll talk about those two things a little bit, not too much, because then we'll talk about the organic compounds. Organic compounds of your body are proteins, carbohydrates and fats. So those are the organic compounds. We'll talk about those three organic compounds. Then we'll talk about the source of energy and enzyme. So first, if you see the smallest component of the body, that is the atom. So atom is the smallest component. Now atoms form elements. And elements join together to form molecules. And molecules join together to form matter. So if you see from the smallest component is the atom. And now if we use the symbol of an element by only one letter, for example here potassium, this is indicated by uppercase K if only one letter is used to indicate the element. If we use two letters, the first one we use the uppercase, second one lowercase. For example, sodium, N, A. N is capital, upper letter, A is lowercase. Same calcium. Okay, so that's how we indicate the elements, and two or more elements join together to form a molecule. Hydrogen, two hydrogen and one oxygen join together, that forms the water molecule. Okay. And two nitrogen, two nitrogen join together to form a molecule of nitrogen. If I want to indicate the element of nitrogen, only one N. So this is the element of nitrogen. Now this is the molecule of nitrogen. Two nitrogen elements or atoms join together to form the molecule. Then matter. Matter is anything that occupies space. Okay, so anything around you that you see that occupies space is a matter. Matter exists in three forms: solid, liquid and gaseous. Okay, so can be present in solid form. You see in this room so many different things, right, that occupies space, and all these are matters. Liquid occupies space, we know that. Gas also occupies space, right? If you put air in your tire of the car, it gets bigger, right? So air also, or gas also occupies space. So matter can be existed in three forms. Elements cannot be split by simple chemical reactions, or ordinary chemical reactions cannot break the elements. However, we can break the elements by special chemical reactions, and if you break the element, what you will find? You will find the atoms, right? Because atoms build the elements. So atoms are the building blocks of elements, elements are the building blocks of molecules, and then matter. Now if I break the elements, then I will get the atoms, and this cannot be done by ordinary chemical reactions. Now if you see inside an atom, you will find subatomic particles. Subatomic particles are electrons, protons and neutrons. So these three are present inside the atom, and these are called subatomic particles: electrons, protons and neutrons. Okay. Now we will see where these subatomic particles are located. If you see an atom, it has a nucleus in the center and a shell, which is the outer part. Okay, and this is the nucleus. Now in the nucleus you have protons and neutrons. So for example, in this atom there are three protons. Protons carry positive charge, so easy, PP, protons positive. So here you have three protons, that means three positive, and in the nucleus you also have neutrons. Neutrons are neutral, also easy, N. Neutrons don't have electrical charge. On the shell, you have electrons, and electrons are negatively charged subatomic particles. So protons are positive, neutrons are neutral, electrons are negative. And protons and neutrons are located in the nucleus, and electrons are located on the atomic shell. Is it clear? On the outer shell. Now, this atom is a neutral atom. Why? Because you see, it has 3 plus, 3 minus. Make sense? So 3 plus and 3 minus, equal number of positive and negative, will make it neutral. So atoms are neutral. Atoms are neutral because of equal number of protons and electrons, positive and negative. Now, in an atom, if you see the protons and neutrons in the nucleus, the number of protons and neutrons are usually same. That's why you see here, I did draw 3 protons and 3 neutrons. So in the nucleus of an atom, the number of protons and neutrons is same. Now, if any reason, if the number of neutron increases, for example, this doesn't happen usually same, but sometimes that can happen. If one more neutron is added somehow here, then this atom is termed as an isotope. So this is now an isotope. The number of neutron is different than the number of proton in the nucleus. Make sense? So in an atom, number is same, but in an isotope, the number of neutron is different than the number of proton. Make sense? Is different. Now, sometimes what can happen, due to that unequal number of protons and neutrons in the nucleus, the isotope, not always, sometimes the isotope can start to emit radiation because of that unequal number, instability can be created here. Unrest can be created here, and that nucleus can start to emit radiation. In that case, this isotope will be known as radioisotope. Make sense? Have you heard radioisotope? So, not all isotopes are radioisotopes. If the nucleus emits radiation from an isotope, that is a radioisotope. Okay? So, now you know atom, isotope, radioisotope. Isotopes are used for some good purposes. For example, to preserve the food, okay, we use certain isotopes. Radioisotopes could be very harmful for the body, can kill the living cells of the body, radioisotopes. But now we know how to use the radioisotopes for our better, purposes. For example, radioisotopes are now used in X-ray to take the picture, because radiation can pass through the soft tissue and go inside. Okay, so we can use that in controlled way. So it will not cause harm, but will pass through the tissue, and you can take the pictures. Okay, so radioisotopes are used in X-ray or other imaging techniques. Radioisotopes are also used to treat cancer or tumor, because we know that radioisotope can kill the living cell, right? Now we want to kill the cancer cell or tumor cell, right? Those are harmful cells. So we can precisely, present the radioisotope on the tumor or cancer tissue and kill them. So these are the good uses of radioisotopes. Now, the atomic number and the mass number or atomic mass. Again, this is an atom, and this one got 3 protons, 3 neutrons, and the atomic number, very simple. Atomic number is the number of protons in an atom. So since this atom has 3 protons, the atomic number of this atom is 3 in this case. Okay, so very simple. The number of protons in the nucleus indicates the atomic number of that atom. Atomic mass is the number we get by adding the protons and neutrons. So the mass number or atomic mass of this atom is 6. So the number of protons in atomic number and atomic mass or mass number is 6 if you add protons and neutrons. Now, since you know that in an atom the number of protons and neutrons is same, so always the atomic number is half of the mass number, because these two are same in number. Now in an isotope the mass number is different, because we know that in isotope the number of neutrons is not same as the number of protons. Make sense? So the number of neutrons, for example here, this is an isotope because the neutron is more than the proton. So in this case, what is the mass number? 7. So in an isotope the number is different, the mass number. So those are few important things about an atom. Now, if you see the major elements in your body, in your body there are many different elements, but only 4 elements form about 96% of body mass. So these 4 elements are actually forming about 96% of your body mass. Only 4 elements: oxygen, carbon, hydrogen and nitrogen. So you need to remember these 4 names. And there are many other elements present in your body. Those are also very useful but present in a smaller amount. For example, calcium, phosphorus, potassium, sulfur, chlorine, magnesium, iodine, iron, sodium. So those are other elements, some other elements, not all, but those are very important too. For example, calcium. Calcium is very important element in your blood. the concentration of calcium in your blood goes little bit below normal, that is called hypocalcemia, and that can cause muscle paralysis of the muscle, and can stop breathing, because we know that we use the muscles to breathe, right? The thoracic muscles or chest muscles. So hypocalcemia can cause paralysis of the muscles. Can also cause tetany, severe convulsion. So you see, calcium is a very important element. Another example, iron. Deficiency of iron can cause anemia. We know that. Iron deficiency, anemia. Have you heard that? Iron, lack of iron. So those are present in a small amount, but very important for your body. All atoms have protons and neutrons in the nucleus except the hydrogen. Hydrogen is an exception. Only in hydrogen you don't have any neutron in the nucleus. So this is a hydrogen atom. So in the nucleus you have only one proton, and on the shell only one electron. So it is neutral, but no neutron is present in the nucleus. So that is exception. All other atoms have protons, neutrons, both in the nucleus. Electron cloud. This is something interesting. This is 2D. When we draw the picture, we draw 2D. But actually, the atom, if you see the atom, nucleus is inside and it's spherical, and the electrons are orbiting, moving, encircling around the nucleus. Always, electrons are not stable, always moving like this. Protons and neutrons are sitting inside in the nucleus, but electrons are always moving, okay, on the shell. And electrons are not moving in one plane. For example, one electron is moving this way, another electron is moving this way, another electron is moving this way, okay, in different planes. So around the nucleus, the electrons are moving in different planes. So if you see from outside, it gives you a impression of a cloud. It's very simple. If you tie 3 or 4 keys with a string and move like this very fast, you will see circle, right? If you move very fast, something like this, you look circle. So you just think that several circles are moving like this in different planes. So from outside, it will give you kind of a square. So that's the electron cloud. From outside, it looks like that, because of the motion of the electrons around the nucleus. An atom could have only one shell or more than one shell. If an atom has more than one shell, for example, this one has 3 shells, outermost shell is called the valence shell, and the electron can be present in all those shells, and those electrons are present only on the outer shell, on the valence shell. These electrons are called the valence electron. These are not valence electrons. This one is the valence electron, because that's the electron present on the valence shell. I think check it. Okay, so the information is the atom could have one shell or more than one shell, and if more than one shell, outermost shell is called the valence shell, and the electron or electrons on that shell are the valence electrons. Here you see the hydrogen atom in the left. It doesn't have any neutron, only proton, only one, and one electron that I showed you a few minutes ago. But helium has two protons, two neutrons, two electrons, right? Lithium is different. So we have talked about already atomic number, mass number, right? Oh, Le. So I will start first. VAL. Okay. Valence shell, valence electron. Isotope, radioisotope. We have already talked about this. Now, the chemical reactions. Inside the body, many chemical reactions are taking place all the time, right? We know that. Many chemicals are present in your body. Now, chemical reactions can occur by forming ions. What is an ion? If you see, this is again an atom. For example, this one has again 3 protons. Probably I like number 3. 3 neutrons and 3 electrons. And we know that electrons are negatively charged and protons are positively charged and neutrons are neutrals. So this atom is neutral because equal number of positive and negative. We know that all atoms are neutral. Now, there is another atom here. This one has 2 protons, 2 neutrons and 2 electrons. So this is also neutral. So 2 atoms, atom A and atom B, both are neutral because equal number of protons and neutrons. Now, if they come closer, these 2 atoms come close to each other, and if there is an empty or open spot on the shell, valence shell, for an electron, but this is just an empty spot or space for an electron. So when these 2 atoms will come close to each other, what can happen? One electron can jump from here to here because there is a seat here. So that happens sometime when they will come closer. This electron will take a chance, will come here. Okay. Now you see this atom has lost an electron, right? Makes sense? This electron has moved from here to here. So now you tell me, this atom got 3 positive and how many negative? 2, right? Because one has left. So what will happen? This atom is no more neutral, right? It will become what? Positive, positively charged, right? Because it has 3 positive, 2 negative. So 1 positive more. Make sense? And this one, you see, got what? 1 electron more. That means 1 negative more, right? It has 2 positive but 3 negative now. So this will become what? Negatively charged. So by losing electron, the atom becomes what? Positive, right? And by gaining or receiving electron, atom becomes what? Negative. Make sense? Because electrons are negative. So if you gain negative, you will become negative. Is it clear? So this process is called ionization. Ionization is the process by which the atoms gain electrical charge. Is it clear? Atoms are normally what? Neutral, right? Atoms are normally neutral. But if the atom gives up electron, it will become positive, and receives electron, it will become what? Is it clear? Yes, sir? Okay. So this process is called ionization. So ionization is the process by which the atoms gain electrical charge. It could be positive or negative. So now the negatively charged atom is called an anion. So negatively charged atom is now known as an anion, and positively charged atom is known as cation. C-A-T-I-O-N. Okay. So anion, negatively charged atom; cation, positively charged atom. Now, when the atoms gain electrical charge, it could be positive or negative either. When an atom gains electrical charge, these atoms are now known as ions. So what kind of ion negatively charged one? Anion. What kind of ion the positively charged one? Cation. But both are now ions. So ion, and that process of gaining electrical charge is called ionization. Now, when that ionization occurs, one atom becomes positive, another becomes negative, and they are close to each other. So what will happen? An attraction will be formed, and that is the ionic bond between the ions. Ionic bond. So positive and negative, they will attract each other. They will attract each other. That is the bond. Attraction is the bond. Okay. So that's the ionic type bond. Three types of bonds are very common in the body. Those are ionic bonds. I have already explained here how the ionic bond is formed by ionization. Other two types are covalent bonds and hydrogen bonds. Ionic bond is formed by donation or receiving electrons. We have seen here. So I believe it is clear to you. Now covalent bond. Covalent bonds are formed by not donating or receiving electrons but sharing the electrons. For example, this is one atom. This one has 4 electrons. And this is another atom. This one has 6 electrons. Now, in covalent bond, what happens? Electrons don't leave the atom. What happens? The electrons get attached to each other. Not all, few electrons of both atoms get attached to each other. side by side like this and form the covalent bonds. So by sharing the electron, now we can say these 4 electrons are the parts of both because they got attached to each other. So that's the covalent bond. Not by donating or receiving, but by sharing. Okay. Now, how many pairs of electrons are being shared? That is indicated by the lines. For example, if sometimes you see in the chemical formula, we write like this. Okay, these lines. What are these lines indicate? These lines indicate how many pairs are being shared to form the covalent bond. So if you see 2 lines, that means 2 pairs. So in this case, we'll say 2 lines. About the anions, cations. This is something interesting. 2 atoms are talking to each other. See, first one is saying, damn, I lost an electron. The other one is asking, are you sure? This one is saying, I'm positive. So you already know, by donating the electrons, you will become what? Positive, right? Because electron is negative. So if electron leaves, you will become positive. So that's how it happens in ionization. Here they have shown the process of ionization, exactly what I have explained to you. You see, sodium and chlorine, when they come close to each other, the valence shell, that means on the outermost shell of chlorine, there is an empty spot shown by the dotted circle, and from the sodium, valence shell of sodium, one electron will jump to that empty spot. Now, since electron is leaving from sodium, sodium will become positive in the right side, you see on the top, and since the chlorine is receiving the electron, it will become chloride, negatively charged chlorine, and then they will attract each other, and that's the ionic bond to form the sodium chloride. Here you see 2 nitrogen atoms. In the right side you see 3 pairs of electron are being shared, right? Not all, on the valence shell, and that is forming nitrogen molecule. So here you see N and 2 nitrogen atoms. When they join together, N2 is the molecule, right? That I explained at the very beginning today. That atoms combine to form molecules. And in the right side, since 3 pairs are being shared, you see 3 lines or bands. Hydrogen bonds. Hydrogen bonds are the weakest bonds. Covalent bonds are the most common and strongest bond. Okay, and hydrogen bonds are very weak bonds. And in your body, hydrogen bonds are mostly present between the water molecules. So water molecules in your body is mainly water, we know that. So water molecules in your body are attracted by the hydrogen bond. So we know that water is H2O. So this is one water molecule. 2 hydrogen, these are weakly positive, and 1 oxygen, which is weakly negative. Okay, this is H2O, the water molecule. This is another water molecule. Okay, so again, okay. This is another water molecule. Same way, 2 hydrogen, weakly positive, 1 oxygen, weakly negative. So when the water molecules get closer, the weakly positive hydrogen attracts weakly positive oxygen, positive negative, right? Positive negative, positive negative, and these are the hydrogen bonds between hydrogen and oxygen. Hydrogen bonds hold the water molecules in your body together, and we know that water molecules try to stay together. Few examples: if you see a pond, sometimes you see small insects walk on the water, right? They can walk because of surface tension of water. That surface tension is created by hydrogen bonds. The molecules, water molecules, are attached to each other by hydrogen bond. If you put your finger in water and take it out, you'll see a nice ball of water is formed in the fingertip, right? To take it out, the water ball is formed because water molecules try to stay together. That's why that ball is formed, right? Water ball. So that's the hydrogen bond. Attract the water molecules or hold the water molecules in your body together, which is very important, extremely important. Um, when the fluid in our body move, the molecules stay together so they can move together. For example, blood. When the blood circulates, right? The blood is mainly water, and the water molecules stay together, so it can circulate inside the system. So this is surface tension of water, which is created by the hydrogen bond. So those are 3 types of bonds: ionic bonds, covalent bonds, and hydrogen bonds. Those are common type of bonds that hold the molecules or atoms in your body together. Chemical reactions. You know that many different chemical reactions occur inside the body, right? Always chemical reactions are occurring. Now, we can group all those chemical reactions into 3 types of reactions: synthesis reactions, decomposition reactions, and exchange reactions. Synthesis reactions occur to produce new compounds from smaller molecules. So, smaller molecules join together to form a larger new compound by synthesis reaction. For example, all the synthesis reactions are being taken place in your body. Glucose molecules. You know, glucose are very small molecules. These are glucose. If you take too much sugar or glucose, the excess amount of sugar that is entering into our body will be converted to a larger compound. The glucose molecules will join together and will form a larger molecule that is called glycogen. So you see, from a smaller glucose molecules, a larger glycogen molecule is formed, and your glucose will be stored in your body as glycogen in the liver and muscle. So this is a synthesis reaction. Okay. Another example, amino acids. We know that amino acids, these are small molecules, and inside your body what happens? Amino acids join together, linked together to form chain by peptide bonds. So these are called peptide bonds. Okay, these are peptide bonds. They link the amino acids and form protein chain. So this is a protein molecule. Protein molecule is a chain of amino acid, nothing but a chain of amino acid. So you see, from smaller amino acid molecules, one long protein molecule is formed. This is also synthesis. So from a smaller to larger molecule or compound, that's the synthesis type of reaction. Now decomposition is just opposite. You know the word decomposition, right? Breakdown. After death, what happens? The body is decomposed, right? We always use that term. So decomposition is breakdown process. So now this is the stored form of glucose in your body. Now if you are starving, your body needs glucose, you are not getting glucose from outside, what will happen? This glycogen breakdown will occur to release the glucose. Okay, and that is decomposition. Okay, breakdown from larger to smaller. So larger compounds or molecules release the smaller molecules. So synthesis reaction usually occurs to do what? Store the molecules in your body. Make sense? Like if you take too much glucose, your body doesn't need now. So what body will do? Will convert the glucose to glycogen and will store. So synthesis reactions occur to store, and decomposition occurs to break down and supply the need of the body. So those are, now if I, here this is a protein chain. Now if I break the peptide bonds, what will happen? The amino acids will be released from the protein chain. So that is also decomposition. The opposite of synthesis is decomposition, breakdown. Okay. Exchange reaction. This is another type of chemical reaction that occurs inside your body all the time. Let me give you a good example. This is sodium hydroxide. If you have chemistry background, you should know in high school. Sodium hydroxide is a base, and this is hydrochloric acid. So this is a base, this is an acid, we know that, sodium hydroxide, hydrochloric acid. When these two chemicals come close to each other, chemical reaction occurs between base and acid. And what happens, you see, this sodium and this chlorine will join together to form the sodium chloride, which is a salt, you know that. And these two will get together to form H2O, water. H2O. 2 hydrogen, 1 oxygen, which is water. So you see, in this reaction, what is happening? Their parts are exchanging the position, right? This one is going attached to this one is going and getting attached to this one, right? To form sodium chloride, which is salt, and water, which is neutral. So this is a very good example of exchange reaction, how the parts of different chemicals exchange their positions, or the chemicals exchange their parts. So I gave you examples of synthesis reactions, decomposition reactions, and exchange reactions, right? So those are three very common type of chemical reactions occur in your body. human body consists of both organic and inorganic compounds. You must remember at the very beginning I mentioned that. So what are the inorganic compounds? Most common inorganic compound is the water. Water is the most abundant chemical in your body and which is an inorganic chemical. Other inorganic chemicals are salts, different types of salts, acids and bases. Inorganic compounds usually don't have carbon in the chemical structure. Organic compounds are carbohydrates, fats, proteins and nucleic acids. So these are the organic compounds. These four are the organic compounds. Others like water, acids, bases, those are salts, those are inorganic compounds. And all organic compounds, you have carbon. So if you see the chemical formula of proteins, carbohydrates, fats, nucleic acid, you will always find carbon in it. So that's why if you see that chemical formula of, for example, carbohydrate, CHO, carbon is there. Okay, lipid, CHOP, carbon is there. Okay, so organic compounds always have carbon. Since water is the most abundant chemical in your body, we need to know the properties of water. Okay, if you see a living cell, about 60 to 80% volume of a living cell is water. So you see, your body consists of hundreds of billions of cells, and all those cells are mostly water. So human body is mostly formed by water. Now, properties of water. Water has some important properties and those are extremely helpful for your body. One is high heat capacity. What is high heat capacity? Water can hold lot of heat in it, and the advantage of it is that water will not quickly turn cold or hot. That is the important thing. Water does not get hot or cold quickly. That is very important. Your body is mainly what? Water, right? Now if water turns to hot quickly or cold quickly, what will happen? Your body will quickly turn to get hot or cold. Make sense? But that doesn't happen. Even if you go to a cold place, very cold in winter morning outside, we go, right? Your body will not turn to cold quickly. Make sense? Because of water. If you go to Las Vegas, where the temperature is 120, right? Your body will not suddenly get 120. That will not happen because of water. So that is very important for your survival. If your body quickly turns to 120 or 30, you will die. If your body temperature quickly goes down, hypothermia, all the systems will fail. Okay? You will not be able to survive if it stays like that. So that is a very important property of water. Make sense? Will not get cold or hot quickly. You know that when you boil the water, you put it long time, right? You put the water in a pot and turn the stove on, and it takes time. Slowly, right? The water gets hot. When you make coffee, you start to drink, right? And it stays hot for a long time, right? It will not quickly get cold. If it turns to cold, you will not enjoy coffee, right? It stays hot for a long time. Why? Because of water. It will not quickly turn to get hot or cold. high heat of vaporization to turn into vapor. What is that? Listening music? That's it. Alarm. Okay. That's fine. So, water will not turn to air or gas quickly. And that is another very important for your survival. Your body again is mainly water, right? So if water turns to vapor quickly, you will disappear. Right? Your body will shrink quickly because water will leave the body. Right? That doesn't happen. So that is another important property of water. Body's major transport medium. Most of the chemicals of your body are transported by the water. For example, the chemicals transported by the water in your blood. Your blood is mainly water, and you know that blood transports gases and other important chemicals, nutrients, and metabolic wastes. So, water transport the chemicals in your body from one place to another. Hormone is transported by the blood to water. Necessary part of hydrolysis and dehydration synthesis reaction. Many chemical reactions are occurring in presence of water, because you all know if the chemicals are in dry state, reaction will not occur. If I put two dry chemicals together, usually chemical reaction does not occur. Now if I mix them in water and then mix them together, reaction occurs. So most of the chemical reactions, just know this is important, most of the chemical reactions in your body occur in presence of water. Dry chemicals will not, reaction will not occur between them. That is one. Number two, water participate in hydrolysis and dehydration synthesis reactions. Those two types of reactions. Hydrolysis, hydro means water, lysis means breakdown. In some chemical reactions, water breakdown occurs. That is necessary, breakdown of water. In some chemical reactions, synthesis of water occurs. For example, I gave you the example a few minutes ago. Sodium hydroxide and hydrochloric acid. You remember this? Sodium chloride, which is salt, and water is produced, right? So in this reaction, synthesis of water occurs, right? Production of water. Water molecule is formed. So this is an example that some chemical reactions use water, some chemical reactions produce water. Cushioning. Water protects your important organs in your body. For example, around your brain, you have the cerebrospinal fluid. You know that, right? The fluid around the brain called the CSF, cerebrospinal fluid. Around your spinal cord, you also have cerebrospinal fluid. Around your heart, you have pericardial fluid. Okay? Around your abdominal organs, what kind of fluid do you have? Anybody? Peritoneal fluid. Have you heard that? Peritoneal fluid is inside the abdomen. So those are different fluids mainly formed by water. Fluid is mainly water, and those fluids protect your important organs. Again, cerebrospinal fluid around the brain and the spinal cord. They are protecting the brain and the spinal cord. Pericardial fluid around the heart, protecting the heart, right? Around the lung, you have pleural fluid. Around the abdominal organs, you have peritoneal fluid. So all those are water, and they are protecting your important organs in your body. Sometimes you ride the roller coaster, right? Suddenly moves from one direction to another, right? Your head moves all the time, right? When you are driving, if you brake the car, right? The body suddenly moves. So, if there was no fluid, cerebrospinal fluid, between the brain and the hard skull, if there was no fluid, what would have happened? The brain would hit the skull, right? And that will cause the damage of the brain. The brain is a very soft organ, right? That doesn't happen because of that fluid or water from the organ. Okay, so very important function. Okay, so you have learned a lot of things. We have talked about the atoms. We have talked about the chemical reactions, ionization, different types of bonds, right? You have learned about the water, organic, inorganic compounds. Most important and common inorganic is the water and the properties of water. Acids and bases, these are inorganic compounds. So acids are the chemicals that quickly donate or release hydrogen ion. Okay, so acids are the chemicals that can quickly release hydrogen ion. Bases are the chemicals that can quickly remove hydrogen ion and quickly produce OH, hydroxyl ion. So acids quickly release hydrogen, bases quickly produce hydroxyl to remove hydrogen ion. That's very simple. Opposite. Now, anybody, can you name just one acid? You know that. And hydrochloric acid, I have talked about that, right? So hydrochloric acid, HCl, right? This is hydrochloric acid. Why this is an acid? H2O is water, which is not an acid. The reason is both have hydrogen, right? Both have hydrogen, but this is an acid because it can quickly release the hydrogen immediately. Now, if you see two acids, this is hydrochloric acid, another acid, this is carbonic acid, just know that both are acids. Now, if this one can produce more hydrogen ion, both can quickly release hydrogen ion, but this one can do more than this one. This will be, so both, you see, quickly release hydrogen ions, but this one produces more, this one produces less. So this is stronger, this is weaker acid. Okay, so that's how the strength of acid is determined. How quickly, how fast, how many hydrogen is being released. Is it clear? So the one releases more, that one is strong. Make sense? So that's how we decide which one is stronger, which one is weak acid. So that's the acid. Now, example of bases. I mentioned you a few minutes ago, the most common base is the sodium hydroxide, NaOH. This is an ideal base. Now, why this is a base? Because this one can quickly release or produce hydroxyl. So when this one will break, it will quickly release OH. Now, this is hydrochloric acid. This is sodium hydroxide. Hydrochloric acid will quickly release hydrogen, right? You know that now. And sodium hydroxide, this base, will quickly release OH. So when they will get together, you see what will happen? It will release hydrogen, it will release OH, and these two will quickly get together and form water. So the hydrogen will be removed. Make sense? Hydrogen is being quickly removed by this hydroxy to produce water. So that's why I said here bases remove free hydrogen and produce water. Make sense? So just one thing about pH, hydrogen ion, and the acidic and base. The relationship, this relationship is very important. If the hydrogen ion concentration is more, the pH decreases. So if hydrogen ion concentration increases, the pH gets lower, decreases. This is a very important relationship you must know. So more hydrogen means less pH, means more acid. Less pH, more hydrogen means more acid. Now if I add more hydrogen here, pH will go down. As I add more hydrogen, pH will go down. Okay? And as pH goes down, it becomes more and more acidic. Is it clear? Make sense? So low pH means acidic, high pH is towards alkaline. Okay? And neutral is what? pH neutral is what? Anybody? 7. 7.2, right? This is neutral, water. Now, if the pH goes down, acidic, that means more hydrogen. If pH goes up, alkaline. Okay? So that's the relationship, very important. So here you see some of your household stuffs, their pH, and neutral is 7. That's the important thing here. As you go down, more and more acidic, and as you go up, more and more basic or alkaline. So above 7, everything is alkaline. Below 7, everything is acid. Organic compounds, carbohydrates, fats, or lipids, proteins, and nucleic acid. Just quickly know that if you see a carbohydrate molecule, you will always find 3 atoms, C, H, and O. So in a carbohydrate molecule, you have carbon, hydrogen, oxygen. Must be present, those 3. And carbohydrates are divided into 3 types: monosaccharides, example glucose; disaccharides, example maltose; and polysaccharide is the most complex and larger form of carbohydrate, and example starch and glycogen. I showed you glycogen, glucose molecules join together many glucose to form a larger molecule, that's the glycogen. So 3 forms of carbohydrates. Lipids. If you see the chemical formula of the lipid molecule, either CHO and sometimes you will see P. So if you see P and then CHO2, that is definitely a lipid or fat. But if you see CHO only, it could be lipid or carbohydrate. just know three types of lipids: triglycerides, which are also known as neutral fats, phospholipids, and steroid. Triglycerides are present in the blood. Phospholipids are present in the cell membrane. Mostly cell membranes are phospholipid bilayer. And steroids are present mostly in the hormones in your body. So those are the common locations. Triglycerides in the blood, phospholipids are mostly in the cell membranes, and steroid hormones. Fatty acids can be present in two forms: saturated and unsaturated. Some of you already know which one is bad for your health, saturated or unsaturated, right? So when you do shopping, right, you check if there is saturated fat, and that's not good for health. But saturated fats are yummy, you know that, right? Very tasty. So cheese or butter or cheese, those are saturated fats. Saturated fats are present in solid form in room temperature. So cheese or butter, those are in solid form, right? Unsaturated are usually in liquid form, present in liquid form. Saturated fat. Why one is called saturated, the other is called unsaturated? There is a reason, right? Saturated is heavily filled by hydrogen ion. That's why it is called saturated. It is saturated with hydrogen, plenty of hydrogen. In unsaturated, you have less amount of hydrogen. That's why saturated and unsaturated. Another thing about saturated, unsaturated, saturated fats mostly come from animal sources. Unsaturated plant sources mostly. And saturated is harmful for your body because saturated fat has a tendency to get attached to the wall of the artery or blood vessel and can block the artery or make the artery narrow. So what will happen? The flow of blood will be reduced. So that's the problem. Can block or make the artery narrow. Unsaturated fats are not yummy, but your friend. Friend in a way that will not cause harm, right, to you. But saturated is yummy, but will cause eventually what? Harm to your body, right? Can block the artery, could be harmful. So, who is your friend? Who is your enemy? You have to decide. Sometime I asked in one class, and one student said, I still love saturated. Saturated is my friend. So if you love to eat, saturated is good, right? But if you don't care eating, you care your health, then unsaturated is your choice. Protein. If you see a protein molecule, you must find nitrogen. CHO is everywhere. CHO is everywhere, but P is only in lipid, N is only in protein. Nitrogen is only in the protein molecule. So if I ask you in the test, if you see CHO and N, that is what? Protein, carbohydrate or fat? Protein, right? If you see CHO and P, fat or lipid, right? If you see CHO, that could be lipid or carbohydrate. Make sense? So last thing, the use of energy. You know that metabolism produces ATP, and ATP is the source of energy in your body, and that ATP or energy is used in many physiological processes, functions in your body. Almost all functions need energy. For example, when the transport occurs across the cell membrane. This is the cell membrane. When the molecules get in, get out, there are some doors there, channels, gated channels. To open the gate, close the gate, you need ATP. So here you see this is closed. To open it, you need ATP. Muscle fiber contraction, you need ATP. Chemical reactions, you already know now that the molecules or atoms must come close to each other for chemical reactions. So energy is needed to bring them together. Otherwise, chemical reactions will not occur. So these are just 3 examples, but there are hundreds. So got it? So ATP, adenosine triphosphate, splits and releases phosphate. That gives energy. And from ADP, adenosine di. This is triphosphate. One phosphate is released, so it becomes diphosphate, and this one gives energy. This free phosphate provides energy. Okay, so let's stop here. If you have any question, you just go over the things and think. Okay, that is important. Try to connect.